This conference will now be recorded.
So, very good evening, students. Good evening, Deepa. I don't know why this happens. Okay, now it is stable. So, Deepa, we had started with the last chapter of 12th standard, that is communication system. So today we'll be learning very important and very interesting part of this communication system, that is amplitude modulation. Obviously, we have three types of modulation with continuous wave. We'll discuss those things in the type of communication systems. So basically, we'll be concentrating today this amplitude modulation. Before that, I'll tell you what are different types of communication systems available, and that is depending on the nature of the information or mode of transmission or type of transmission channel. So according to nature of the information system, communication systems can be different. Okay, like speech transmission. For speech transmission you need radio. So fast communication, types of communication system according to nature of information. Nature of information. Okay, so there are three types, actually three in this category. One is speech transmission. For speech transmission, I'll write first the communication system, that is the radio. So this is for speech transmission. Okay, then you have fax. You might have learned this or heard this, fax. So fax, it has a full form. I'll write in the bracket. So facsimile transmission, it is called facsimile transmission. FACSI, facsimile, facsimile transmission. Okay, or okay, let me tell you about what is exact full form of fax. It is actually, fax is facsimile, that's all. Facsimile. So what is done in this facsimile transmission? Actually, some still pictures or documents like admit card or mark sheet, if you have one if you left your documents at home and you have gone for interview in Delhi, so how do you get your documents? If somebody can fax you, you will get. So generally still pictures, documents, these are transmitted. Then still pictures, documents. But nowadays, due to technological advancement, basically with the mobile apps, nowadays this is very much uh, like it is very less used transmission or communication systems nowadays, because you have mobile, good camera, you have a good scanner, you scan and send it, right? But earlier it was not there, so that's why this was very popular, office to office transmission. Okay, then if you have both picture and speech transmission, picture and speech both, then what you use, actually that is a television ta- television communication system. So television is used transmitting for transmission of both speech and speech and picture, okay, together. Now the fourth one is data transmission. That is, see, this is done nowadays. This is done nowadays in computer, okay, transmission of data, like as in computer. So this is according to the nature of the information which we use to transmit from one place to another. Like if you have only speech, then radio. If you have only still pictures or document, etc., so for that we can use fax. But as I said, nowadays we don't use much this thing. Television for transmission of both speech and picture, and data transmission we do in case of computer, right? Now we'll see there are various other category also, depending on the, now we'll see according to the mode of transmission. According to mode of transmission, second type is according to mode of transmission. According to mode of transmission, okay. So according to mode of transmission, the communication systems are mainly of two types. One is analog type, analog analog type, analog communication. So here the signal which modulates the carrier signal for transmission varies continuously. In the sense the signal is analog, okay, you can say that signal is analog. It is used for analog signal, analog signal, okay. And digital communication, digital communication, this is for this is for analog signal means continuous signal, and this is for pulse uh, or quantized or discrete signal, for discrete or quantized signal, quantized signal, okay. So these are just as an information you can keep in mind. Later, whenever we require, we'll go into detail. Now, according to mode of transmission, it was according to mode of transmission, this one digital and analog, but mode of transmission channel, according to mode of transmission channel, whatever channel we use or mode of medium, like according to the medium, you can say, according to the mode of transmission channel, according to the mode of transmission channel, what are the types of communication systems we have? We have basically line communication and space communication. Two types. One is line communication, and in this line communication, what are the medium we used? We use various things like 2axial, like two wire line communication, two wire. Generally, wire is used, two wire communication, or coaxial cable communication, coaxial cable. These are actually according to the mode of transmission channel. Okay, channel means the medium we use for communication. Either two wire we use, or we use coaxial cables. Okay, or the third one is nowadays very much popular. There is the optical fiber. Optical fiber. It is fast and less. Uh, Actually, it doesn't lose the signal, the strength of the signal. Actually, without much attenuation, you can transmit your signal for long distance. Okay, so that's why this optical fiber nowadays are very popular. Okay, and space communication. This is space communication. You just remember the name, that there are different types of communication. Like in this case, space will be used, or vacuum will be used. Not vacuum, I should say space. Space will be used as communication channel. Okay, like I think we can give radio signal, like radio communication in this. Or nowadays, nowadays mobile and etc. you are using. So those communications are using the space for transmitting our information from one place to another, because all the signals we use in this case actually the radio signal. Okay, radio wave. This is one type of electromagnetic wave. Okay, now we'll see according to type of modulation. Actually, according to type of modulation, there are, okay, let me clean this portion. We have, so far we have discussed according to the nature of the information, then according to mode of transmission, whether it is analog or digital mode of transmission, then according to mode of transmission channel we use, like line wire, line communication, or space communication. Line communication means we use two wire or coaxial cable or optical fiber, and in case of space communication, like radio wave, etc., like whatever telephonic communication, wireless communication happens, that happens through space. Okay, wireless communication, you can say. Space communication means wireless communication. Now, the fourth category of communication systems are actually according to according to according to the type of modulation. Type of modulation. Modulation we had already discussed a little bit, but I'll just recap, and obviously we will be discussing what is amplitude modulation today. Modulation means if you have a signal like speech signal, okay, some music, so those signals will have very low frequency, and low frequency signal cannot be transmitted for long distance. So for that we use a we use a carrier signal to carrier wave to carry this signal, original signal. Okay, so the original signal is superimposed with the carrier wave, and that carrier wave will transmit the signal from one place to another, and that's how the original signal will not be uh, distorted. It will obviously it will be superimposed with the carrier wave, but there is modulation as well as demodulation. At the receiver you have the demodulator, so which will actually separate out the carrier wave and the original signal. So according to mode of modulation, there are two types actually. One is for continuous, let me write continuous, sorry, carrier wave. So where the carrier wave is a sinusoidal function which has a continuous variation, continuous carrier wave. Okay, I can give you some example in this category. One is amplitude modulation, which I am writing in short. Okay, let me write amplitude modulation. In short, it is written as AM, A dot M. Somewhere it will be written, or sometime it will be written AM simply. Okay, this is not for morning time. Okay, this is amplitude modulation, at least in this communication system. Then you have FM. FM, you are familiar with the battery. This word comes with battery. So frequency modulation. Frequency modulation. Okay, so this is named as like in short it is written as F dot M. Then phase modulation. These are actually involved with continuous carrier wave. Okay, so this is phase modulation. So phase modulation, in short it is PM. Okay, so AM PM you have both here. PM is not for post so this is not involved with the time now. This is with the phase modulation. Okay, M for modulation, P for phase. Now if you have pulse carrier wave, then there will be with pulse carrier wave there will be further some categories of communication systems like pulse amplitude, so PAM. So in everywhere you will be written PAM. Then anyway it doesn't have FM, then pulse time modulation, PTM. So pulse time modulation in case of pulse carrier wave. Okay, I'll just write here with pulse carrier wave, with pulse. Then with pulse carrier wave, what are the modulations you have? You have excuse me, pulse modulation, pulse amplitude modulation, pulse amplitude modulation, amplitude modulation. Okay, so this is written as PAM. Okay, then you have pulse time modulation, PTM. What is that? PTM, pulse time modulation. Okay, pulse time modulation, it is PTM. In the pulse time modulation also there are two different communication systems are used, like pulse position modulation and pulse width modulation, or pulse duration modulation. Okay, pulse width modulation or pulse duration modulation, and the first one was pulse position, PPM, pulse position with, okay, here there will be no page, this one. So in the pulse time modulation, PTM, there are subdivisions here. One is PPM, that is pulse position modulation. Okay, pulse position modulation, this is called PPM. Then pulse width modulation, pulse width, PWM. And pulse duration modulation, you might be very much bored with this, but don't worry, we have already finished this the different types of. These are just for your information, what are the types of communication systems we have. And actually, different types of communication systems will give you different bandwidth. Like say standard AM or amplitude modulated broadcast will give you this much frequency bands. If you remember, frequency band means any signal can have lowest frequency, suppose f0, and highest frequency, some f, or let us write this as f1 and this is f2. So the difference between the f2 and f1, this highest and lowest frequency, that is called bandwidth. Bandwidth. Okay, bandwidth. So this bandwidth is actually required for good communication. Okay, for very good communication, we need this bandwidth better. If you have more bandwidth, then communication will be, quality of the communication will be more. Uh, okay, FM broadcast uses this much bandwidth of the frequency, and similarly for television there are various bands. Like see, TV is generally operated this, then ultra high frequency, then you have again very low frequency TV and ultra. Uh, okay, so these are various bands and the uses over here. Like cellular mobile radio, that uses this particular bands. Okay, mobile base station, and from the base station to mobile. So these are frequency bands. And satellite communication, there are bands like gigahertz in the range of gigahertz. Okay, so it has again uplink and downlink. So according to that, their frequency ranges are different. Anyway, so we have learned various type of communication systems, radio, television, fax, etc. according to nature of the signal, according to the nature of the mode of transmission, according to the nature of the transmission channel, according to modulation. Okay, now we'll learn amplitude modulation in detail. So what is modulation? We had already discussed. Sometimes there will be low frequencies which cannot be transmitted for a very long distance because it will be attenuated, or the strength of the signal will be lost before it reaches to the receiver. So a high frequency carrier wave is used to carry the audio signal. Generally, audio signal is very low frequency signal. Okay, so modulation is the process. I'll write the definition first of all. What is the modulation? Definition of modulation. So modulation is the process by which some characteristics by which some characteristics some characteristics usually amplitude. Some characteristics means the characteristics of the signal. Okay, of the signal. Some characteristics usually amplitude, some cases frequency or phase, angle of high frequency carrier wave of high frequency carrier wave is varied according to the instantaneous value instantaneous value instantaneous value of the low frequency signal is called the modulation. Okay, so modulation is the process by which some characteristics, usually amplitude, frequency or phase of high frequency, is varied according to the instantaneous value of the low frequency signal, and the signal is called the modulating signal. Modulating signal. The signal is called modulating signal. Okay. Okay. So now we'll see there are so as we see the definition, amplitude, frequency, or phase. So these will be varied. Okay, let me just explain you this definition. So modulation is the process by which some characteristics like frequency or amplitude or phase of a carrier wave. What is carrier wave? Carrier wave. Suppose this is the message signal, okay, which I need to transmit from one place to another. But you look here, this has very low frequency. So you have a carrier frequency here. Sorry, carrier signal you have, carrier wave you have here. You can look that there. So it has frequency. At least you have to have frequency or amplitude. You have to have at least double, less than, like this should have less than 2 times of the frequency. So the carrier wave has larger frequency. Okay. And when we superimpose these two, that means the signal, message signal and carrier signal, then the resultant will give you such variations. Okay, look here. So this amplitude, carrier wave amplitude doesn't change. Actually, it has a constant amplitude. Okay, constant amplitude. Look, this is the carrier wave. Carrier wave amplitude is constant in this case. But the signal, original signal had change in the amplitude here, 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 here. It has changed in the amplitude. So the amplitude of the carrier wave will be changing accordingly, and you can see this is the resultant modulated amplitude modulated signal. This is amplitude modulated signal. So this signal is called carrier signal. This is called modulating signal or message signal, and this is called modulated signal. This is called modulated, the one you get after superposition. Modulated signal. Okay, so this modulated signal, you can see the envelope. This envelope is changing with the frequency of the original signal itself. So amplitude of the carrier wave changes according to the instantaneous values of the original signal. Okay, if you just see with very rapt attention, you can see the amplitude is just increasing up to here, then again decreasing, then it is becoming minimum over here, almost zero, and then again in the other cycle it is again increasing, like that it happens. So the amplitude of the carrier signal changes with the instantaneous value of the signal, original message signal. Okay, now we'll discuss a little bit in detail about amplitude modulation. So in the amplitude modulation, we have seen that amplitude of the high frequency carrier wave is changing according to the instantaneous values of modulating signal. Modulating signal mean the original signal. Okay, look, this is the general definition. This is the general definition of modulation. I'll write the definition of the amplitude modulation. So amplitude modulation, it is the process in which amplitude changes. Okay, it is the process where, okay, It is the process in which the amplitude of the carrier wave changes according to the values, sorry, instantaneous values of the original or the message signal, or the original signal. Okay, all right. Now we'll try to understand what are the factors in this amplitude modulation, etc. We'll discuss now. Let me repeat discussion on this particular figure itself. Let me write few terms over here. Let me do one thing. I'll just increase the size of this figure in another page, and we'll go on discussing this. Okay, let me enlarge little more. Okay, so it will be better visible now. So amplitude of the carrier wave changes according to the modulating wave, and during positive half cycle of the modulating signal, the amplitude of the carrier wave increases. I mean to say, in the half cycle, or you can say during each quarter, when it is increasing, then amplitude increases, and another quarter of the cycle, here the amplitude decreases. Okay, this is how it goes. Thus the top and bottom envelope modulated envelope of the modulated wave are just a replica of modulating signal. See, in this case, if you just forget about this ups and downs, you look only this envelope. This envelope is exactly having the same amplitude like your original signal, message signal. This is the envelope. It is called envelope of the modulated signal, and you have maximum value here, and you have minimum value of the amplitude over here, right? So we need to derive. See, we need to know there are important features of the amplitude modulation, or okay, let me write important features of important important features important features of amplitude modulated wave. That means the product wave. So what are the features of this resultant wave? Because we are getting upon superposing these two. Okay, this is the signal, this is the carrier wave. We superimpose them, and then we get this kind of signal. Okay, this is called amplitude modulated signal. I am writing AM signal or AM wave. Okay, so what are the important features? We see that the amplitude of the carrier wave changes according to the modulating signal. First of all, amplitude changes. Amplitude of the carrier wave changes according to the message signal. This is one, signal. This is first feature. Second feature is that the amplitude of the carrier wave changes at frequency FM and the modulating signal. Okay, so the frequency also you can see now. The amplitude changes with frequency. Amplitude of carrier wave changes with frequency. Carrier wave changes with frequency. Changes with frequency of with the frequency of the modulating signal or message signal. And third feature is that the frequency of the modulated wave is equal to the unmodulated carrier frequency. These are two points, important points. The frequency of the amplitude modulated. Okay, here it is amplitude modulated, so I'll write a dot m wave. Frequency of the amplitude modulated wave is equal to the frequency of unmodulated carrier frequency. Okay, carrier frequency. That means the frequency of the amplitude, or see, you look here, frequency of the amplitude modulated wave is equal to the frequency of the carrier wave. Okay, so that is what we'll see. So this is actually the amplitude of the carrier wave changes with frequency of the modulating signal. So that we have seen, this is how it changes. But the frequency of the modulated, see, frequency you have like, this is half a period, then you go here, you have a complete period. So you have a frequency of unmodulated carrier wave, so that we should understand. Now we'll go to mathematical derivation of modulation factor. There is something called modulation factor. Okay, so we'll see what is modulation factor, or depth of modulation. We'll discuss up to that today, or if time permits we'll discuss even how to write a modulated wave equation. So modulation factor or depth modulation. We'll now discuss modulation factor. Modulation factor or depth factor. Oh, sorry, depth of modulation. Depth of modulation. So it represents the extent to which the amplitude of the carrier wave is changed by modulating signal. Okay, how much the carrier wave amplitude is influenced or changed by the, sorry, it is like, yes, it represents the extent to which the amplitude of the carrier wave, it represents the extent to which the amplitude of the carrier wave is changed. And it is defined as the ratio of the change in the amplitude of the carrier wave to the amplitude of the original carrier wave. So it is defined as, so if I write that as mu, it is defined as, so this is denoted by mu, modulation factor or depth of modulation. This is the ratio of change in the amplitude of the carrier wave to the amplitude of, sorry, amplitude of the original signal of original carrier wave. Okay, so change in the amplitude. Okay, let me write this as am by AC. AC is the amplitude of the carrier, original carrier wave, and this is the change in the amplitude of the carrier wave. So change in the amplitude of the carrier wave AM can be written as maximum mx minus a min divided by 2, and AC can be written as a max plus a min whole divided by 2. That means, see, the depth of modulation factor can be expressed as the ratio of a max minus a min. This is of the modulated wave. This is of the modulated wave. Max and min I am writing in terms of modulated waves. Maximum amplitude of the modulated wave and minimum amplitude of the modulated wave, and divided by this. Okay, and this value generally lie between 0 to 1. The mu lie between 0 to 1. Okay, this is the modulation factor or depth of modulation. And sometimes if you want to express in terms of percentage, then you just multiply 100 and you get percentage of modulation, percentage modulation. So a max minus a min divided by a max plus a min. A min is amplitude. Okay, so I think if we start with the equation of amplitude, like amplitude modulated wave, then it will go another half an hour. What I'll do, I'll take up as a continuation of this amplitude modulation part. Like how do we see if we write in terms of carrier wave? Suppose I can write a carrier wave C of t is equal to AC into C into t. This is the frequency of the carrier wave, and this is the amplitude of the carrier wave, and this is the instantaneous value of the carrier wave. If I take carrier wave like this, okay, and I know the mu factor, then what will be the instantaneous wave of the modulated wave? Okay, modulated wave. I should write CMT. What will be? How do you write the modulated wave? I'll tell you. What you have to do is 1 plus mu into sine omega c. Here there will be AC into t. So kind of this, we'll see that modulated wave has a particular way of. Okay, so I think it is inside omega m t into sine omega c t. Okay, this part we'll discuss in the next class. Okay, on Sunday. I'll stop it here for today. Deepa, you might be having very many doubts. You can ask me during the class or at the end of the class, or maybe at the end of the chapter when I discuss about the numerical problems. Okay, in that way you have to learn each concept. Do you have any doubt for today's class?
No, sir.
Okay. Okay, then we'll stop it here. Bye for today.
Thank you, sir.